improved debugging. Windows PowerShell version 2 offers some great debugging techniques above and beyond what was in version 1. So we're going to start by talking about the step debugger, which was in version 1 and is still useful. We'll also talk about breakpoints, which is new in version 2, and integrated scripting environment debugging, also new in version 2. Another version 1 feature we'll revisit is the write debug commandlet, which is really useful for generating debug output in your script. So the whole theme of this nugget is going to be techniques and technologies and tools for debugging your scripts more effectively. Now, to get us going, I kind of want to show you a script that I've introduced a couple of simple bugs to. One of them, I didn't actually mean to, that should be an equal sign. Don't worry if you spot the bugs right now. The point of this is not to see how quickly you can debug. The point of this is to help walk you through the debugging process and introduce you to the debugging features in Windows PowerShell. Because we're going to look at 2 or 3 ways of debugging this. So basically what I'm doing is I'm reading the name of a computer, and then I'm going to retrieve the Win32 logical disk class. I'm only getting the instances that match this filter from whatever computer was specified. Now when that's done, I'm going to pipe it to this kind of complex select object. I've used backticks here. This is really only 2 lines. Line 1 is the read host, and line 2 is everything else. The backtick escapes the carriage return, turns it into sort of a line continuation character, just so I can kind of fit this all in one window for you. Anyway, what I'm doing is I'm grabbing the server property, __ server property, that all WMI objects have, and I'm renaming it to computer name. I'm also grabbing the device ID property, and I'm grabbing the size property, dividing it by 1 GB, and casting it as an integer, which will remove any fractional component. And that's going to be in a column labeled total space. Last up will be a column labeled free space in megabytes, which does basically the same thing with the free space property, only it divides it by 1 megabyte and casts it as an integer. So I'm actually going to come down and run this from the command line. So if I get a dir here, I've got my debug.ps1. Let's just run it. Computer name to query. We'll say, let's call it Win2008R2. Ooh, null or a bad argument. Okay, well, folks, this is why it's a nugget on debugging. Let's look at the first debugging option PowerShell offers, which is called the step debugger. Set-psdebug-step. Do you want to continue with this operation? Yes, please continue. Please continue. Continuing. Okay, so hopefully I'm in debug mode now, and that's what debug mode looks like. Let's run my script again. Do you want to continue running the script? Yes, I do want to continue running the script. Continue with this first line, and you'll notice that it shows me the line number here. Actually, when I'm doing this, you know what I'll do a lot of times is I'll print out a copy of my script with line numbers down the side, so I can kind of have that sitting next to me. If you've got a large enough screen, a lot of screen real estate, maybe you can spread out windows. But when it's telling me it's running line 1, I like to be able to kind of look at line 1. So let's run this. Okay, so now it's running line 1, and I'm going to type Win2008R2. Now here's my methodology. I don't want to run line 2 yet. I've just changed the contents of a variable. So I want to suspend. Notice my little different prompt there with the 3 angle brackets. I'm inside the script. The script is actually paused, and it's waiting for me to continue. And now I can manipulate stuff. So since I just put a value into the variable computer, let's take a look at it, $computer. Oh, wait, it's empty. All right, well, that wasn't what I expected. And because I had an expectation that what I had just typed, Win2008R2, would be in this variable, my expectation and reality are different. That's where my bug exists. So there's no point in me continuing. I'm going to exit suspend mode and tell it no to all and stop running the script. And then I'm going to come back over here and look. And my problem was I didn't put my host name into computer, I put it into commoputer. Simple little typo. So we'll fix that. Boom. Come back down here to the command line and try it again. Let's run debug. Yes, please continue. Yes, let's run the first line. Win2008R2. Suspend. Let's look and see what made it into the computer variable. Hey, it's there this time. Fantastic. We'll exit, and now we will continue and run line 2. Yes, please run line 2. Okay, continue with this operation. Looks like we got some sort of error message going on. Not sure Not sure what exactly the deal is. We'll just hit yes to all so it can finish running, and it says invalid query on the WMI. And that's a little trickier to debug. So let's see, what can I do here? I'm actually going to turn debug mode off at this point. Set PS debug off. Because all that yes no gets annoying. And I'm just going to try and run that query manually. Get WMI object, Win32, logical disk, filter. I only want the drive type that equals HDD. And let's do it. Let's not even involve a remote computer. Let's just see if it works against the local computer. No, it doesn't. All right, so I've kind of narrowed down my problem by attempting to manually run the line that I was having a problem with, and by simplifying it a little bit, I've definitely narrowed down where the issue was. That's the same error. So let's just decomplicate it. Let's take the filter off completely. Oh, see there, the drive type property is a number. It's not actually HDD or whatever. So let's see, C is a hard drive, so 3 must be a hard drive. D, that's a CD, so that's 5 probably means optical. A, that 2 probably means floppy. So I can come back here and say I want the drive type to actually be equal to 3. Let's save that and come back here. And the reason I'm switching back and forth is because this step debugger that I've been using really only works in this command line environment. So let's just run debug again in 2008 R2. Hey, there it goes. So we successfully debugged the script. And that's the step debugger. That's one great way to do debugging in Windows PowerShell. But that was a way that existed in version 1 too. And we want to start talking about some of the new stuff that exists in version 2. So I'm actually going to go back to my script and put my typo back in. And you'll see why I do that in just a second. And I'm going to look at the first command here. It's called set PS breakpoint. Now what this does is it sets a runtime breakpoint. And I can set it on a particular line or column, and that's this. I can say, okay, in this script file, I want you to break when you hit this line and or this column. And when you do break, here's what I want you to do, and that's optional. Or I can say, I want you to break whenever this particular command runs, or I want you to break whenever this variable is read, written, or either. So let's try that latter one. Let's set a PS breakpoint, and I want to break when the computer variable is read or written. Okay, so I've defined a breakpoint. Now let's run debug. Computer name to query when 2008 R2. And oh, it entered debug mode because it hit a variable breakpoint on computer, read-write access. But you know, this isn't what I expected. I told it to bug me when it read or wrote, and it's down here on line 2, which is the get WMI object, where it's actually reading the variable. Well, wait a minute, what's in $? See, I'm automatically suspended. You can see I'm in debug mode, and I've got that 3 angle bracket prompt. What's in computer? Oh, nothing. Well, that's a problem. Why is there nothing in computer? And, oh, look, it's because I had that typo there. So we'll change that, save it, go back into the shell, exit debug mode, let the error come through. Still breakpoint, still got that breakpoint. In fact, let's look at the breakpoints. It's still there. It's a variable computer. And let's run debug again. Computer name to query when 2008 R2. Ah, see, this time it hit a breakpoint when I wrote to it. So I can now take a look inside there and see what was in there and everything else. Let's just go ahead and exit it and see if it still works. Now it's hitting a breakpoint again, exit, and it worked that time. So the idea is that by setting breakpoints, you can have it automatically stop at a certain point. Think about a really long script. Think of a script with 200 or 300 lines, and you have a problem on line 150. With the step debugger that I showed you first, you've got to sit there and go yes, 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 yes for the first 149 lines until you get to the point where you think you have a problem. By setting a breakpoint, though, you can have it stop on a particular line. Hey, look, I know the first 149 lines are fine. Just break on line 150. Or you can say, I want you to break when this variable is changed or when someone tries to read this variable. So wherever that occurs, I want you to stop and give me a chance to look at things. Or you can say, I want you to break whenever a particular command executes. because that's where I think the problem is coming up. So whenever you run into that command, I want you to break. In fact, let me show you an example of that. Little breakpoint management, get PS breakpoint, remove PS breakpoint, and that gets rid of them all. And let's look at help PS, set PS breakpoint again. So one of my other options was to set a command. So I want to set a PS breakpoint on the command get wMyObject. Okay, now let's run our debug script. Computer name to query, Win 2008 R2, and ooh, hit a breakpoint. You were about to run get wMyObject. Okay, since this was giving me an error the first time around, this is where I might say, okay, rather than running this from the script, let me just run it here and see what I get. In fact, I'm just going to copy that to the clipboard, paste it, and okay, it ran fine, so when I hit exit, it should run fine, and it did. It got me my results. So that's kind of an interesting way to work with debugging. Now, it definitely takes a little getting used to. If you look at the commands that use the noun PS breakpoint, we've looked at get, we've looked at set, we've looked at remove. You can also enable and disable breakpoints. So if you've got one set but you want to temporarily turn it off, you can disable it, and that leaves its definition in there so that when you want to use it again, you can enable it. Using these from the command line is definitely a little bit, takes a little practice, I guess. You kind of have to get used to why they're there and where they're working with. So it would be kind of neat if you could do this from a graphical environment, sort of a Visual Studio style debugging. And you absolutely can. I'm going to right click here and toggle a breakpoint. So it turns dark red, lets me know that that's a breakpoint. And you can kind of do that anywhere you want to. Toggle a breakpoint right there if you want to. Now let's just run it from within this environment. Oh, hit a breakpoint. Okay, so I ran that first line, now we're on a breakpoint. Go ahead and continue. So I'm typing down here, my results are here in this upper portion of the pane. So let's let it continue. Computer name to query, Win 2008 R2, and boom, 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 it goes through. You'll notice it did not hit the second breakpoint that I set, and that's kind of a trick. Remember I said that this is really all one line? Well, it is. These little backticks are allowing me to wrap it around on multiple lines, but this is really all part of the same line. So I'm going to toggle that breakpoint off. If you want a breakpoint, it's got to be at the beginning of the line. So I would have to set it here on line 2. Setting it on line 3 really just sets a breakpoint in the middle of the line, and this ISE doesn't really allow for that circumstance. So this is definitely an easier way, I think, to be able to debug, because in a long script you can just go, toggle breakpoint, stick it there on whatever line you want it to, let it run to that point, and then you'll get your debug prompt to work with. Now let me offer you a little bit of debugging advice. Turn that breakpoint off. I had originally 2 errors in this script, and so that's what they were. There's only 2 reasons that PowerShell scripts run into a problem. 2 broad reasons. There's a lot of tiny little reasons, but broadly speaking, reason number 1 is typos. You just typed something wrong. Now, relying on the color coding can help, but in this case, this is a perfectly valid variable name, and so it colored it red, and I might not have noticed it. So just read carefully. Type carefully, read carefully. When things aren't working, make sure everything's typed correctly. The variable names can really be tricky. That's one of the reasons I like to use nice long variable names. I don't like variable names like, A or X or B, because with one character, I think it's even easier for me to get mixed up and mistype it. The other thing I had was here. And this is actually what I find for me is the #1 cause of bugs and errors in a script. And it's the trickiest to track down too. And sort of the top level problem is you either have a variable or an object property that doesn't contain what you think it contains. See, I was working under the assumption that the drive type property would contain something like HDD for hard drive and CD or DVD for an optical drive, maybe floppy or FLP for a floppy drive. But that wasn't the case. In fact, this property contains a number, and it was 3 that I wanted for a hard drive. I could have looked that up ahead of time, but who looks things up ahead of time, right? You just start typing stuff and you see what works. So anytime something's not working, you need to reevaluate all of your assumptions. Let me show you another really simplistic example. I am going to use getWMyObject to retrieve the Win32 service class from a remote computer named Win2008R2. I am then going to pipe that to whereObject because I want to filter out. I only want the ones where the status is equal to running. Oh, and I've got that breakpoint in there still. Let me get rid of that real quick. That's funny. Get PS breakpoint, remove PS breakpoint. Got to remember what you do in the shell too. So let's try that whole command again. And I got no results. So wait, you're telling me that the entire Win2008R2 computer doesn't have any services that are running? This is another case where I've made a bad assumption about what a particular property contains. Let's back off of that assumption and just look at the Win32 service object. And in fact, let's just select the first one and have all of its properties formatted as a list. So let's look for that status property. The status is OK. If I was looking at stopped and started, here we go, running. That's actually the state. So I needed to have state equals running, not status equals running. So if I come back and modify, now I get something useful. So again, the biggest trick with debugging and the biggest type of error that I often run into is when a property value or a variable doesn't contain what I thought it contained. And the right debugging technique is to back off a little bit and look at the object and see what it actually contains. And the little trick I just did, selecting the first one and piping it to format list star, is a great technique. It means you don't have to go up on Google or Bing and try and look this up on the web someplace. You can just look inside PowerShell and see what those properties actually contain. And when you're looking at a status of OK, OK, is there a running or running? And that's how you can arrive at the correct solution just a little bit quicker. So again, typos and things that don't contain what you think they contain. A way to get to those is using the step debugger or breakpoints, because that allows you to stop the script in the middle of the game and see exactly what is inside of a variable or what's inside of an object property. Now I'm going to show you one other debugging trick, and this is called the write debug commandlet. Write debug, let's just say script starts. I like to put a write debug anytime my script has made a decision or changed the contents of a variable. Write debug computer is $computer. Now because this is in double quotation marks, this is going to be replaced with the actual contents. And so before I do something, write debug querying WMI. And then when I'm finished, I'll put in a little write debug script ends, just so I kind of have some status information. So let's save that, go down to the shell so you can see what this looks like, and I'll run my debug. Computer name to query Win2008R2. Oh wait, where's my debug output? Oh, there's a trick. Debug output is suppressed by default. There's a built-in variable called debug preference, and I'm going to set it to continue. The default in the shell, if I look at debug preference, is silently continue, and that's what suppresses the output. My script will change that, but it'll only change it for that script. So if I run debug again, now I start seeing my debug output. This allows me to verify that the value I typed actually went into that variable, and it helps keep me up to date on what's happening. If I look at the debug preference variable in the shell, it's still set to silently continue. So I've only turned debugging on for my script. When I've finished debugging, there's no need for me to go remove all these write debug statements. In fact, I like to leave them in there because I might have to debug this script again sometime in the future. I just want to suppress their output. There's no performance hit here. The output is still being produced, the shell's just not displaying it. So if I save it now, go back to the shell and run debug one more time. Now my debug output is turned off and I can run my script in production mode. If I ever need to make changes to it and need to debug again, I simply change this back to continue, and my debugging is all ready to go. So again, just some little techniques, because bugs occur when you mistype something or when something contains a value you didn't expect. So all of those techniques, the step debugger, setting breakpoints, and even write debug, can help you figure out exactly where that differs, and that helps you squash the bug. This nugget has been about squashing bugs in your scripts. We looked at the step debugger, which allows you to step through a script one line at a time, suspend the script to examine variables and objects, and make sure that everything's the way you expected it to be. Now in a long script, that can get to be pretty tedious. So version 2 introduces something called breakpoints, which allows you to tell the shell, hey, I don't want to step through every single line, but when this happens, or when you get to this line, I want you to stop automatically and let me do some debugging and investigation. You can do some of the same stuff right from within the ISE, which gives you a graphical, right-click sort of way to do it that can be a little bit easier to approach than using all those PS breakpoint commandlets. And finally, if you want to just kind of get a better look at what's going on inside your script, you can use the write debug commandlet to produce debug output that's easy to turn on and off. I hope this has been informative for you, and I'd like to thank you for viewing.